Hey, third grade. I decided to make an extra video this week. I know that the week 6, day 3 lesson that Ms. Fisher is doing with you on YouTube is really long and it's really challenging. And so I thought that I would make a video that you can go back and watch before if you start to have a hard time, because a lot of you might. It's a lot of information, it's really long. And we were kind of in the middle of it when we went to distance learning, so it might be really challenging for you. So I've created a little review and we're going to do that together. Okay, so this is a review of fractions that are greater than 1. And like I said, you might want to watch this before or during the time that you're working on week 6, day 3, which Miss Fisher did the YouTube video for, okay? So the first thing we really need to talk about is, what is a fraction greater than 1? A fraction greater than 1 is any fraction that is bigger than 1 whole. So fractions greater than 1 have a greater numerator than denominator. In case you forgot, the numerator is the top number and the denominator is the bottom number. So the top number here, in this example of 3/2, 3/2, obviously we know 3 is bigger than 2. So this is telling us that there are 2 pieces to make each whole, right? This is 1 whole and this is another whole. And there are 1, 2, 3 halves shaded. Another example here is 4/3. 3 parts in 1 whole, 3 parts in another whole, and 1, 2, 3, 4/3 are shaded. The last example is 5/4. There are 4 parts to make a whole, and 1, 2, 3, 4, 5 shaded fourths, 5/4. Okay? The next thing we need to talk about is fractions that are equal to a whole number. What does that mean? A fraction equal to a whole number is a fraction that is equivalent to a whole number with no fraction remaining. These fractions have a numerator that is divisible by the denominator. And I made this word look a little different because this is really important. The way we can figure out if a numerator is divisible by a denominator is simply by dividing or multiplying. So the first example I have here is 2/2. It's written as 2/2, and we represent it here. This is my 1 whole, and there are 2 parts. Next, I have 4/2. So here's, again, 1 whole, and then another whole. So 4/2 is actually equivalent to the whole number 2. Just like this is equivalent to the number 1, 1 whole, 4/2 is 2 wholes. The last example here is 6/2, and that is equivalent to 1, 2, 3 wholes. So this word divisibility is telling us 2 divided by 2 is 1. So 2/2 is equivalent to 1 whole. 4/2 tells us 4 divided by 2 is 2. So we have 2 wholes here. The last example of 6/2, 6 divided by 2 is 3. 6/2 is equivalent to 3 wholes. And you can do that with any example, any denominator. We're gonna do some practice here. So if you have pencil and paper and you wanna do it with me, you can. If you wanna just watch, that's fine too. But we're gonna plot halves on this number line. You see I already have my endpoints here. There are 0 and 5. I need to first plot my whole numbers. So if I have 0 and 5, I'm missing 0, 1, 2, 3, and 4. So I need 4 lines for my whole numbers first. So I'm going to use this tool and I'm going to draw 4 lines that are going to represent 1, 2, 3, 4. And I'm just doing this as best I can to kind of make it as even as possible. It's probably not perfect, but that's okay. And then I can use, I'll go with my marker and I'll just quickly write 1, 2, 3, and 4. Now below, that's where I'm going to represent my fractions. But before I can do that, I only have fractions. I'm sorry, I only have whole numbers on my number line right now, and I need my fractions too. So each whole is going to be decomposed into halves. And I want you to hold up how many fingers to represent the amount of parts one whole would be decomposed into to make halves. Hopefully you're showing me the number 2. 2 parts means 1 line, so I'm going to get back to drawing lines, and each whole, here's 1 whole, decomposed in half. Another whole, in half, in half, in half, in half. Now, we are ready to plot our fractions. So we're obviously going to start with 0. How many halves are equivalent to 0? Hopefully you said 0 halves. And next we would have 1 half, so you could record 1 half. Then we're looking at our whole number. How many halves are equivalent to 1 whole? 2. So here I have 2 halves. And then you can continue labeling 3 halves. I didn't do the halves, I just did the whole numbers, but you can write 3 halves, 4 halves, there's 5 halves, 3 wholes equivalent to 6 halves. Oops. 8 halves, and get rid of that altogether. We have 10 halves there. So you might notice when we look at our numerators, our top numbers, we go 0, 2, 4, 6, 8, 10. We're skip counting by 2. 2 is our denominator. So each of these numbers, 2, 4, 6, 8, and 10 is divisible by 2. There wouldn't be any fractions left over because those are our whole numbers. We can do that with thirds too. So if you want to do another one with me, you can draw another number line, and our endpoints are 0 and 3. We need how many whole numbers between? We have 0, 1, 2, 3. So we need 2 lines to represent 1 whole and 2 wholes. Now we need to decompose each whole into how many parts? For thirds, 3 parts. 3 parts means 2 lines. So each whole from here to here. Oops, I didn't label these. Let me label these. So I know what these whole numbers are, 1 and 2. And then I can do my lines. Okay. Each whole from 0 to 1 is 1 whole. 2 lines to make 3 parts. 1 part, 2 part, 3 parts. 2 lines here to make 1, 2, 3 parts. And one more time, like this. Okay? And we always start at 0. How many thirds are equivalent to 0? Hopefully you said 0 thirds. And then you just continue on 1 third, 2 thirds, 3 thirds. I can write these in too if it's helpful to see all of them. We're only focusing on the whole number equivalents right now, but it's helpful to sometimes see and to write all of them. So we have 3 thirds here. That would be 4 thirds, 5 thirds, 6 thirds, 7 thirds, 8 thirds. Can you predict what would be next? We're talking about thirds and we have 3, 6, 9 thirds. So hopefully that's what everyone has there. So we see 3, 6, 9, and we know 9 divided by 3 is 3, or 3 times 3 is 9. So really knowing our multiplication and division quickly and fluently will help with this. As always, you can always go back and you can watch the fluency videos with Miss Julie, and those help you memorize multiplication and division facts by practicing together, skip counting and looking at the visual pictures. So even if you've already watched them, you can always go back and watch them again. It will never hurt, and it's always good to freshen up. All right, we're gonna do one more together. This one is fifths. So draw a number line if you're doing this with me, endpoints of 0 and 2. We're missing just the number 1. We just have one whole number this time in the middle, so I'm gonna plot that and obviously label it 1 whole because I remember this time. And now we're talking fifths. 5 fifths in a whole, right? 4 lines. So we need 4 lines between these two. 1, 2, 3, 4. And then again here, 1, 2, 3, 4. And then we start to label. We always start at 0. If you feel comfortable, you want to go ahead of me and then check off my work, you can do that. Otherwise, you have 0 fifths. 1, 2, 3, 4. How many fifths equivalent to 1 whole? 5. Very good. And 6, 7, 8, 9. How many equivalent to 2 wholes? Hopefully you said 10 fifths. And your number line should look like that. All right, again, this is just extra practice. If you need it, if you're getting stuck on some of these videos, then that's what these reviews are for, so that you can go back, watch it again, kind of remind yourself. We can break it down a little bit so that you can work on that packet work along with that YouTube video with Miss Fisher for week 6, day 3. All right. Hopefully everybody's doing okay at home still, working hard. We know you're all working really hard. And of course, we're always so proud of all your hard work. Continue to reach out to us if you need help with anything. And we will see you soon. Bye.